Hi guys, welcome to Matrices 9. In the last class of matrices, we have seen the basic properties of the inverse of a matrix. We have seen the basic definition of the inverse of a matrix. And we ended the session by saying that we will be looking at finding the inverse in the next session. So that's what we're going to do here today. We are going to dedicate this session of about 15-18 minutes in trying to understand how to find the inverse of a matrix. My name is Srinivas and I'm here to help you get through your IPMAT entrance exam. All right, so let's first understand the definition of the inverse of a matrix. The standard definition of the inverse of a matrix is, if you remember, A inverse is given by this notation. The formula is adjoint of the matrix A divided by the determinant. So if you remember, what is the meaning of this? This is not modulus. Remember, it is not modulus because for a matrix, this symbol means it is determinant. It is not modulus. Okay. So the formula for a matrix is, or the inverse of a matrix is, adjoint of the matrix divided by the determinant of the matrix. Now, this is the first approach. As you can see, it's method 1. There are two methods I'm going to discuss. This is the standard textbook method that you will see everywhere. Now, we will first understand what is the meaning of adjoint. You might be wondering about that. So, I will explain the meaning of an adjoint of a matrix in the next few slides. Now, for a 2 by 2 matrix, the adjoint is very easy to define. So, if you start with a matrix A, that is A, B, C, D. Now, why am I taking a square matrix? Because we already discussed. For a non-square matrix, inverse does not exist. So, we are looking at a square matrix. So, the smallest square matrix is 2 by 2. 1 by 1 square matrix is nothing but a single element, which is a number itself. So, here, for a 2 by 2 square matrix, if you have A, B, C, D as given over here, then the adjoint of A is defined as D minus B minus C and A. So what is happening here? You interchange A and D and put a negative sign for the other diagonal. You're getting the idea? So that is a straightaway definition for adjoint of a 2 by 2 matrix. I'll show it to you with an example. If I have 1, 0, 4, 5, and I want to find the adjoint of this matrix. This is your A. So the adjoint of A will be, so first you will have to interchange or exchange your diagonal elements, primary diagonal elements. So it becomes 5 and 1. Then for the other diagonal, just put as negative. Negative into 0 becomes 0 itself, so there's no change. But 4, when you put a negative, becomes minus 4. So the adjoint here is 5, 0, minus 4 and 1. This is how you find the adjoint of a 2 by 2 matrix. So according to the formula, if you remember once again, the formula of A inverse is adjoint of A divided by determinant of A. Now, if you remember, the determinant of a 2 by 2 matrix is if you have A, B, C, D. If this is your matrix, then the determinant is AD minus BC, correct? So if I want to find this matrix and the determinant of the original, sorry, you are supposed to find the determinant of the original matrix. So you want to find the determinant of A. It is 5 into 1, 5 minus 0. 4 into 0 is 0. So that is 5. So what is your A inverse? Your A inverse will be 5, 0, minus 4, 1 divided by 5, which basically means A inverse will be, take 5 inside. 5 inside means every element should get divided by 5. So that becomes 1. 0 by 5 is 0. Minus 4 by 5 and 1 by 5. This will be called as the inverse of A. And if you are interested, you can actually try to do this. Find out what is A into A inverse. And you'll actually notice that you will get 1, 0 and 0, 1 for sure. This is a home exercise for you. You can try it out. So finding the inverse of a 2 by 2 matrix is very, very straightforward. It's a very simple idea. This is the direct formula for it. Now, if we move on and try to do this for a 3 by 3 matrix, right? If you try to do this for a 3 by 3 matrix, now the job is not going to be that easy. It's not going to be that simple. The 3 by 3 and higher matrices will make your life really miserable when you're trying to find the inverse of a matrix. So we will look at finding the inverse only for a 3 by 3 matrix. Higher order matrices are beyond the scope of your exam. Don't even bother. Okay, but the properties of inverse of a matrix can be used. But finding the inverse of a 4 by 4 matrix, you will waste your entire exam time. So there is no point in doing that. Okay, now what is the adjoint of a matrix when you are dealing with 3 by 3? Now 3 by 3 matrix or for higher order matrices also, the process what I'm talking about is constant. Whether it's a 3 by 3 or a 4 by 4 or a 5 by 5, it is the same process. But you will realize that as the order becomes higher, 4 by 4 and 5 by 5, that is the dimension become higher, sorry, not the order, the dimension becomes higher, you will notice that the calculations become that much more complicated. So I will show you an example for a 3 by 3 matrix. Okay, so the finding of the adjoint of a 3 by 3 matrix actually has 3 steps in it. It has 3 steps in it. Step number 1 is finding the matrix of minors. If you recollect, in the session where I showed or explained to you the process of a determinant, I showed you what is the meaning of a cofactor. I showed you what is the meaning of a minor. So recollect that. If you don't, please go back and visit that video. Our first step is to find the matrix of minors for the given A. Matrix of minors for the given A. A quick recollection, if you want to find the minor of A, then you will delete these two and you will find the determinant of the leftover, E, F, H, I, and you write it in the place of A. If you notice, in the place of A, I am writing the minor of A. Similarly, I will write the minor of B. Now, what is the minor of B? Very quickly, B is gone. So, D, F, G, I. And you can see D, F, G, I determinant I will be writing here in place of B. Now, similarly, I will write every element's minor. You can see there are 9 elements. I'll just give you one more example. If you want to write the minor of, let's say, H minor becomes H and H gets this column and row are gone. So A, C, D, F. So in the place of H, this is the place of H, you get A, C, D, F. So such a matrix is called as the minor matrix of A, where every element is replaced by its minor. Okay, this is the first step. In fact, this is the most important as well. I mean, all steps are important, but this is the lengthiest step because this involves multiple determinant calculations. While you can say it's a cross product, it's still not that easy. I mean, it will take some time, right? So let's go ahead and take an example and see what happens. I'm taking a matrix A, 1, 4, 2, 7, minus 4, 0, 9, 10, minus 3. And I'm showing to you the first step in terms of numbers. So the minor of 1 is this determinant. So minus 4, 0, 10 and minus 3, right? The minor of 4, if I want, basically will be 7, 0, 9 and minus 3. So when you write all of such minors and simplify, so if you notice this determinant, actually becomes minus 4 into minus 3, that is negative 4 into negative 3 is 12, minus 10 into 0, which is 12 itself. Here, once again, 7 into negative 3 is minus 21, minus 0 is negative 21. So that's what I'm writing here. The third determinant is 7 tens are 70, minus negative 4 into 9. So this becomes 70 plus 36, which is 106. So this way, when you simplify, you get a matrix. This matrix is called minor matrix of A, or it's called simply minor of A. Okay, so this is the explanation with the numerical example of your first step. right? Let's move ahead for the second step. Again, I'm telling you, it is not a short process. This traditional process is a bit lengthy, so you'll have to be patient. Right, the second is actually an easy step. The second step is convert your minor matrix that you just calculated into its cofactor matrix. Now, I also explained to you in determinants video what is the meaning of a cofactor matrix. How do you find the cofactor matrix? Please refer to the video if you are not, if you don't remember it. But I'll quickly go through it. If you can kind of recollect it, this will be helpful. If you have a minor a, the cofactor matrix, the values, that is the numeric, the absolute values will not change, just that the signs will be changed this way. Okay, which means your 12 will be positive sign, so it will remain as 12. Your minus 21 should be multiplied with a negative sign. That's what this means. So minus of minus becomes plus 21. Your 106 will remain positive itself. Your minus 32 will now be multiplied with a negative. So negative of negative becomes plus 32. Okay, so please refer to the cofactor matrix which I explained to you in the determinants video. So you will convert your minor a matrix using the cofactors, or rather you write the cofactor matrix of minor a. So the final what you get here is called as the cofactor matrix of minor a. Right? So you can see that this is the minor matrix. If you remember, we calculated in the previous slide. So plus, minus, plus, minus, plus, minus, plus, minus, plus. So you multiply with the corresponding signs and you get 12 minus into minus is plus, and so on and so forth. You'll get all of these. And this is called as the cofactor matrix of A. This is the end of your second step. This is easy, right? You have it, there's hardly any calculation in this, just change of sign, but you have to be just careful about it. The third step also does not involve too much of calculation actually. The third step is transposing all elements along the primary diagonal. Now I'll explain what it means. First of all, what is the primary diagonal? It is the diagonal starting from left top to right corner, bottom. Right? That is your primary diagonal. You are supposed to transpose all elements along the primary diagonal, which means you will not touch your primary diagonal. That will remain as it is, but the symmetrical elements around your diagonal will be interchanged. So D and B, if you notice, D for Delhi and B for Bombay. Similarly, G and C, H and F, they will get interchanged. So you can see D is going here and B is coming here. So D and B. Similarly, C is coming here, G is going here. So G and C. And similarly, H and F. This is the end of your third step. So if I continue the same numerical example, this is the matrix that I got. What is this matrix? This is the cofactor matrix. Cofactor matrix of minor A. Right? Cofactor matrix of minor A. We just calculated this. This is your primary diagonal. This should not be touched. 32 will come here. 21 should come here. Similarly, 8 and 106 should interchange. 14 and 26 should interchange. When you do that, you will get a matrix like this. You will get a matrix like this. Right? Now, this matrix finally will be called as the adjoint of A. This matrix is finally called as the adjoint of A. Phew, right? Long process. Don't worry. I don't expect them to ask you to calculate the inverse in an exam, but you should at least know for the worst case scenario. So this is how you find the adjoint of A. Once you get the adjoint of A, then you use the formula. A inverse is adjoint of A by determinant of A. So adjoint we just found out. A is given to you. Adjoint we just got. Now the step is to follow the or find the determinant. Now determinant, if you remember, you will write the same first three columns, C1, C2, C3. Then you will write C1 again and C2 again. You will repeat the C1 and C2. and multiply these three, then add them to the product of these three, and add them to the product of these three. I've shown this process in your determinants way of in your determinants class. This is slightly, I will not say faster, but less confusion way. So you'll just multiply diagonals, then you will take the opposite diagonals, that is 9 minus 4 and 2, and take the negative. So minus of 9 into minus 4 into 2. So first three diagonals are positive. The next three diagonals, so this is your reverse diagonal, 9 minus 4, 2. This is your second diagonal, 10, 0, 1. This is your third diagonal, minus 3, 7, 4. If you notice, all of them are getting subtracted. Right? So the red lines that diagonals have drawn are adding. The blue line diagonals that I'm drawing here are going to subtract. Right? So this is what you're supposed to do. When you do this, the final answer you'll notice in this particular question is 308. So according to the formula, the A inverse will be the given matrix adjoint of A divided by 308. Which means if you want to simplify, 308 will get divided by all the elements if you take it inside the matrix. But usually you can leave it here. You can leave it at this point. This is called as the A inverse. Right? As I said, I'm also tired talking so much, but yeah, that is the process. But because you've all been very patient and you've very hopefully listened to me very seriously, I'm going to give you a shortcut to finding the adjoint of the matrix. This shortcut can be useful only for a 3 by 3 matrix. Remember, the previous procedure that we have seen is valid for any level of matrix, 3 by 3, 4 by 4, 5 by 5. But the shortcut I'm talking about is useful only for a 3 by 3 matrix. Okay? Right. So let's take a look at what is this method and how do we use it. We will take the same example, the same A, and we will try to find out the inverse of A using this new method. So the first step is write down the same three columns, then repeat your column 1 and column 2 like your determinant. Okay, repeat column 1 and column 2. Then the extra part here will be also repeat now your full row 1 and row 2. So in determinant calculation, we only repeated column 1 and column 2. Here, both columns and rows have to be repeated. So first repeat columns, then repeat rows. So what do you get? You get numbers like this. Now once you get this set of numbers, delete your first row and your first column. Delete your first row and first column. You want only remaining. You want only the remaining. So take only what is left out. Right? Now we will create our answer directly from here. And I'll explain to you how my answer is coming to you. I will take the first two rows. I will take the first two rows. If you notice, I will write this as my first element. Right? I will write the determinant of minus 4, 0, 10, minus 3 as my first element. Then, if you notice, what am I doing? I will take the next set of 4 like this. 0, 7, minus 3, 9. But I am going to write it vertical, not horizontal. So I have taken the first two rows. The determinants I'm getting from there, I'm writing in the column. So I'm converting the determinants from the rows into column. Similarly, if I do the next set of determinant, I will get 7, minus 4, 9 and 10. That I will be writing in the third element in the first column. Right? So I got my column 1 here. Right? Okay. Next, what do we do? Okay, this is done. Once this is done, you will take the middle two rows now. So leave out the first row. Right? You will leave out the first row. Then do the same process again. This, write it here. Okay. Then these 4 you write it here. And finally, these 4, you will write it here. The same process, right? So this is your column 2. And finally, the same once again. Leave out the first 2 rows. Look at the 3rd and 4th rows. Again, you will get 3 determinants. This is over here. Then 2107 is over here. 147 minus 4 is over here. So this is how you create this matrix. Okay. Then what do? Simplify it first. Right? You finish this. Okay. So simplify it. You find the determinants. You will get 12, 32, 8, 21, minus 21, 14, 106, 28, minus 32. Okay. Same answer you got in the previous method also. But you can see that this method is much more faster than the 3 steps that we have seen. Right? So this is how you find the adjoint. Your job is not done. You still have to find the determinant. Adjoint has to be divided by the determinant. So this is the process to find your adjoint fastly or quickly. Your job is A inverse is adjoint of A by determinant of A. So you got the numerator. You will have to divide this by the denominator of determinant A anyway. So this is the process or the second method where your adjoint can be calculated in a much faster way. So guys, I hope the session has been informative, interesting, and eventful for you. Thank you guys. See you in the next session. You can always reach out to me on my email ID or on my WhatsApp. Always glad to help you guys out. See you.